Okay, so in this video here, we're going to go through some basics of charge, current, voltage, and power. These are essentially, if you're looking at a circuit or any kind of electrical system, these are things you're going to be interested in. Now, I'll be honest here, we're not going to typically talk about charge too much, but I start with charge because charge basically is the foundation of everything else that we're going to be interested in here. Okay, so let's first start off with charge. Now remember that charge has a unit of coulomb, which is just C. Now charge here, the other thing we should remember is charge can be either positive or negative. Now, we will primarily deal with negative charge. Which is electrons, because typically that is what we are talking mostly when we're talking about some of our basic circuit elements, is how the flow of electrons is going in the circuit. Now, it's not that we don't have positive charge flowing as well. In some of these active devices like transistors and diodes, you also do have positive charge mosing as well, but that's really just for the internal operation of those devices. So essentially, whenever we're looking at a circuit, regardless of the components, we're going to be referring to the charge being the electrons. Now, one critical thing here to remember here, and this is kind of the foundation for us, is that charge is conserved. And you might refer to that as energy being conserved. And what that means here is, let's just look at, for instance, if I have a box here, and I just will say this box can, I'll just say, can hold 10 electrons. Actually, I don't want to do that, can hold. So let's say here, this box here can hold any electrons here. So I've got this box here, and let's say that there are 4 electrons coming into this box, and then I have electrons leaving this box as well. And there's no electrons can be in the box. In other words, I can't store any electrons in this box. So 4 electrons comes in, and I have some electrons going out, and I also have another branch. Some of them are coming down here like this. Okay, so 4 electrons are coming in here. What we're saying with the charge being conserved, if there's no electrons in the box, and I can't store any electrons in the box, I have 4 coming in, that means I have to have 4 going out, because none can be in the box, and I can't just randomly create electrons. In other words, I couldn't have 5 electrons coming out here and 2 electrons coming out here, because, well, that would be 7 electrons, and I only have 4 coming into the box. So I can't just magically create electrons in the box, and I can't store electrons in the box. So at the same time, I couldn't have 1 electron flowing out of each of these here, because electrons can't be stored in this box. So I'd have to have some kind of, maybe 3 electrons coming out that branch and 1 coming out of this branch, because that means I've conserved my charge. What's going in is the same as what's coming out. So that's what we mean, like when we say charge is conserved, or energy is conserved, is that I can't just magically created out of nothing. So, and that's true in all senses. I mean, like a battery, it's not just that energy's coming out of anywhere. It's battery's got, you know, an acid and some electrodes, and there's a chemical reaction going on to create the flow of electrons and to create a voltage. All right, so that's what we talk about with conservation. Let's move on here to current. Now, current is what we're going to be dealing with primarily as far as this. We're not going to really worry too much about current, but current is a measure of the flow of charge. Now, here's something we're going to look at is we have what I'm going to call, this is our technical definition. And then we're going to have our actual definition. So our technical definition, first off, let's say we use I to represent current. And you might say, well, why don't we use C for current? Well, we use C for capacitance. So we use I for current. Then the current is defined as I is equal to dq over dt, which Q, I'll put it off to the side here, Q is your charge. Now, some of you might be familiar with what this is saying here, and some of you might be like, well, what is this dq over dt? This is something that is referred to as a derivative. And this is something that's talked about in calculus. Now, not all of you have had calculus at this point, which is fine. We don't really need it for this course. You might say, well, current is defined using some calculus. Right here, you have it. But for what our purposes are in the course, we can think of it in a little bit more general terms and not worry so much about the precise technical definition. So, less precise definition is that my current is equal to delta Q over delta T. And this is the change in charge over the change in time. Now, this is a less precise definition, and technically, if we want to really get technical, this here would be the average current over a time interval. Which honestly is probably good enough for us anyway, because, you know, honestly, we're not necessarily worried about what the current is necessarily at a precise moment. We're just, well, what's the average current? You know, that's often what we're interested in anyway. But this is something easy. This is just like a slope equation here. So basically, if you're wanting to talk about computing this, you'd have, you know, 2 points of data, and you just do Q2 minus Q1 over T2 minus T1. Just calculating a slope. You know, so that's all that is. And that's the one we're going to use. Now, there is a way, and I'll just mention it here. Whoops. There is a way to get charge using current. And I will at least write this down here for us. but I'm not going to go into the details of it. So we can get back my charge by, and this is a weird symbol again, and I will explain what it is briefly, but not go into any kind of details. So we can get the charge back by doing this. Here is something that's called an integral. And again, this is something that's dealt with in calculus. But we're not going to ever need that in this course. So I put it out there just for completeness, and so that when you do see some of these things in your calculus class, you can actually see there are actual reasons why we're interested in things like derivatives and integrals, because we have it right here at the beginning of one of our circuits courses. But for our purposes, we're not going to need those for this course. All right, let's talk a little bit more about current here. An unfortunate thing here for current, and this just has to do with how we defined positive current back in the day. So this is just kind of a historical thing. So if you have a wire here, and we say, let's say we have electrons flowing to the right here. So this is the direction of the electrons moving in the wire. Our current is actually defined in the opposite direction, meaning the positive current would be in the opposite direction here of the flow of electrons. And that's because back in the day, before we really understood how electricity fully worked, we decided to make the flow of positive charge positive current, which, I mean, that makes sense, you know, kind of thing. But we didn't really understand that, you know, most electricity is not due to the flow of positive charge, it's due to the flow of negative charge. So that's why we have that positive current is defined as the direction that's opposite the flow of electrons. Unfortunately, we're not going to have to worry about that too much either. But one thing that's important to know here is we can draw currents, quite frankly, in any direction. So we could draw a current in the other direction, but if we do here, it's just the negative of I1. So in other words, current has both a direction and a value. So current has a direction and a value. Now, I'm actually going to end the video here. Obviously, I didn't meet all the objectives on this video. We'll still get to those in a later video here. But the next video I want to do is I want to do a couple examples with current here to make sure we understand precisely everything with directions of current and things of that nature. Actually, I might do finish up the current and then start it on the voltage. We'll see what we do.